Great intro, thank you. Yes, I wanted to talk to you today about the quantum internet from science fiction to science fact. By the way, funny, on the website it said science face, so I hope you like my science face. Obviously, a lot of the stuff I'm talking about is still science fiction, so please read the legal disclaimer. We're not selling anything, etc., blah, blah, blah. But 5 years ago, on exactly this stage, you probably saw Professor Stephanie Weiner from University in Delft, who talked to you about her big dream of a quantum internet. And although there is no quantum internet yet, and indeed we're still pretty far away from a real quantum internet because we don't even have quantum computers yet, there are already applications that use quantum technology or that could help prevent attacks from quantum computers, because that is obviously the big worry currently. I've met Stephanie somewhat later in 2018 during the RIPE Quantum Internet Hackathon, which took place in Rotterdam. I was asked by Vesna from RIPE to join, help out with some equipment, and she asked, do you know anyone in Juniper who knows something about quantum internet? So I've asked around, and one person responded, who is Credi Compella, you might know his name, who said, yeah, I think the subject is interesting, let's join. So Credi and I joined, and as you can see on the screen, we even wrote a draft for IETF, somewhat looking into how can we use our current network technology and knowledge of how networking works in quantum networks and in a quantum internet. Obviously, the draft didn't go anywhere, but we sort of got started in our journey towards a quantum internet. That was 2018. 2020, Juniper also figured out, hey, we need to do something with this hype of quantum internet. Customers started asking about it. There were huge investments being made. Also, lots of funding became available from both Dutch but also European government, and also in US, obviously. So we founded a small team in Juniper, which we call a pathfinding team. And pathfinding teams are not tied to any product or technology yet, but the teams are looking into, let's say, the future, trying to figure out, in our case, what should we do with quantum technology? What should Juniper do? Should we start building products for it, or should we partner, etc.? So that led to us partnering with QTech, the University in Delft, again with Stephanie Weiner and others from her team, but also with Eurofiber, to build a Dutch quantum testbed. You might have seen some PR about that from late last year. So what we've did, Eurofiber provided fiber capacity, QTech provided technology, which is called quantum key distribution. You might have heard about it. I won't go too deep into it, because then the presentation will take 2 hours, and I think everybody's up for beer by now. But we basically demonstrated how we can enhance current network technology, MACsec and IPsec, with additional key material from this system, which is called quantum key distribution. That was quite successful. We demonstrated that. We've, in the meantime, wrote some production code based on RFC 8784, which describes how you can use some of this key material in IPsec to already make it quantum resistant. And then what? So we started discussing how can we extend the testbed, and what else should we do with it. But before we go into, let's say, the next steps of the testbed, what was actually the problem we were trying to solve? You might have heard by now that at one point in the future, a quantum computer might become so powerful that you can run what's called Shor's algorithm. And what Shor's algorithm can do is factor asymmetric key cryptography. In other words, everything we secure currently, which is based on protocols or algorithms like Diffie-Hellman, etc., could potentially be vulnerable if that quantum computer becomes available. For your idea, the current quantum computers have it's somewhere between 10 and 100 qubits, and in order to run this algorithm, you would need at least 1 million qubits. So we're still far away, but it's probably good to start building that knowledge. And a lot of governments are now also giving out advisories that you should start looking into symmetric key cryptography instead of asymmetric key cryptography. Why is that? Because obviously symmetric key cryptography doesn't rely on PKI infrastructures and doesn't use the vulnerable protocols, as I mentioned, like Diffie-Hellman, etc. But distributing key material is pretty hard if you want to use symmetric key cryptography, right? You cannot have someone flying around the whole world with a suitcase with key material in it. So we've started looking for different ways of distributing that key material. And one of the methods to do so is what I mentioned, this quantum key distribution, for example. So those are, let's say, the first steps towards this quantum internet. Again, there's many limitations to quantum key distribution. Some of you might know about some of the physics behind it. You cannot copy polarized photons. You cannot amplify them using CWDM, DWDM, etc. So it only works in very limited domain. It works probably in the metro, but how are you going to secure a link between Amsterdam and London with such a system? That still isn't there. And the physicists are working on quantum repeaters, and in the end that might lead to routers having quantum repeaters in them, etc. But that is again still pretty far out. However, we can already indeed take these first steps and start experimenting with it, and that is what we did in the test bed. So how does it work if we look at what we've done already in this test bed I mentioned? We have two sites, Alice and Bob, and we have obviously an eavesdropper, and both have a quantum device, which Alice has a device that sends polarized photons to Bob, and both have obviously a router. It must obviously be a Juniper router in this presentation. And in between there is some connections. Between the QKD devices you need a dark fiber or wavelength. Again, you cannot amplify it, etc. So in many cases it's a dark fiber. And they use this fiber to send polarized photons from Alice to Bob. And without again going into all the physics, but if you send a polarized photon, you can sort of compare that with throwing a football. If I would throw a football to you and give it a certain spin, you can only see which side is facing you if you catch the football, because then you see which side is facing you. If you do that sort of similar, compare that to how a polarized photon works. If somebody, Eves in this case, tries to observe this photon while in transit from Alice to Bob, then the state of the polarization changes. In other words, Bob knows at one point that he's receiving photons which have already been collapsed in a certain state. So that is why QKD is considered theoretically secure and can be used for this symmetric key cryptography and distribution of key material. The routers have a classical link in between them, in this case secured by MACsec. And what was specified by ETSI is the ETSI QKD014 REST API that basically describes how you can consume key material from this QKD system. So a request is sent from the router to the QKD device asking for a key and a key ID. It receives both back and it installs the key, in this case in MACsec. Then it sends the key ID to the Bob router, and Bob can now use that same key ID to fetch the key from the QKD Bob side. It hopefully receives the same key, installs the key, and you have what is considered quantum secure connection. Again, this is pretty limited scope due to many of the limitations, but these are the first steps you can already take today to secure MACsec. There are quite a few companies out there that sell these QKD solutions, and there's vendors like Juniper who are implementing code to actually consume that key material. Sort of the same happens in IPsec. As I mentioned, RFC 8784 speaks about how to, let's say, enrich IKE v2 with additional key material. That could be key material from QKD, but could be from other mechanisms as well. It sort of works the same. The steps are a bit, there are a bit more steps to it. First, Alice router informs Bob router that its willingness to use this additional key material. Bob confirms that it also has intention to use that key material. Then the request is sent to the QKD device for a key and a key ID. Both are being sent back. The key is installed in the crypto engine. The key ID is sent to Bob, in this case an SRX, so Juniper's firewall. That uses the key ID to fetch that key from Bob QKD, receives the key, installs it, and it acknowledges that it will use that key for that session. That is what RFC 8784 describes. And this is available today in general available journals 22.4 R1. And if you indeed set this up, then you have a quantum secure IPsec tunnel. So then what? So this is what we've tested. We've demoed this, as you saw in some of the previous slides, doing lots of proof of concepts, also with customers. We've already have some deployments, many obviously in lab environments, but then what? So we thought we need a new partner, and that is AMS-IX in this case. So we are extending, or how do you say it? Maybe it's testbed 2.0, building a testbed with Juniper, Eurofiber, a QBird, which is the spin-off of TU Delft, and AMS-IX, and you can participate as well. So what is the idea behind the testbed? We want to build and share knowledge on quantum safe networking. I mean, we're learning as well in this space. That's one of the objectives of the pathfinding team, because a lot of what is currently happening in this space isn't standardized yet. As I mentioned, there are some RFCs like RFC 8784 that describe how to use key material, and there's REST API defined, but all the rest is not defined yet. For example, how often should you rotate key material, right? Or what should you do in a multi-point environment, or how do you validate the quantum link? There's many aspects that haven't been standardized or tested yet. So that is what we want to try out and start working with also the AMS-IX members, for those who are interested in this and want to start testing themselves. We also want to, what we've been discussing with Eric and Jan and Max from AMS-IX is how can we make AMS-IX quantum secure, right? Should we start using this key material in MACsec to protect the AMS-IX underlay? Or should we offer key material to AMS-IX members, or should AMS-IX become a, let's say, node in a quantum internet and have members have these QKD devices themselves? So there's many things and options we can think about, and we want to think about together on them with the AMS-IX community. So we've done some brainstorming. I've made a few pictures while we're doing this, so sorry about the quality of the pictures. But this is the technology QBird is bringing to the testbed. It's called MDI QKD, sorry. Sorry? Wat zei je, Mark? Measurement device independent QKD. Dankjewel. Mark is, by the way, one of the partners. He's from Eurofiber. So if you want to know more about quantum safe connections, speak to Mark. Thank you, Mark. What MDI QKD is that you have a central node that connects multiple end nodes. So instead of this one-to-one relation you saw in QKD, MDI QKD offers multi-point key distribution. And so you can start thinking about, hey, what if AMS-IX would have one of these central nodes in their network and members have end nodes to exchange key material, etc. So that is what QBird is bringing. And then the brainstorming led to, okay, so should we connect to the AMS-IX switches or to the core, and how should that all work? As you can see, it's still pretty early stage. And we started thinking, because the current testbed is hosted by Eurofiber, should we extend from the Eurofiber data center into AMS-IX, or where should we put the nodes? So we're not there yet. There's no, let's say, concrete plan yet, but the first steps are there. And so we came up with sort of a phased approach where, as I mentioned, QBIRD will connect to the Amsterdam Internet Exchange with their end nodes or central node that is still also in the works as a first step. And then there's two, let's say, tracks. One is indeed thinking how can AMS-IX become the quantum Internet Exchange and or secure the platform itself against attacks from these quantum computers. And the other track is thinking about how can we enable members to start exploring and testing with this technology as well. So this is basically the first, let's say, outreach we are doing as a testbed. As I mentioned, we have implemented as Juniper this RFC 8784 RFC. And so we can help you with the code. It's generally available, but if you're interested, we can get you the virtual firewall so you can start already experimenting with quantum-safe IPsec. And we expect, from a timeline perspective, to be able to connect the first members somewhere early 2024. So how can you participate? First of all, start thinking about, should I do something with this whole quantum technology, right? It depends a lot on what is the value of your data. For some, I mean, if in 10 years a quantum computer is able to factor the security that about my bank statement, I don't really care in 10 years if somebody knows what is today on my bank account. But I can imagine if you have some, let's say, more classified or sensitive data, that it could be interesting to already start thinking about what happens if a store and decrypt attack takes place, if somebody stores my data now and is able to decrypt it in 10 years. Which protocols should we be looking at? As I mentioned, we've mainly been focusing on MACsec and IPsec, but I can also imagine that, for example, BGP MD5 doesn't allow for key rollover, but BGP TCP/AO and LDP TCP/AO does allow for key rollover. So can we use the key material in those protocols? Right, so that is what we ask as a testbed from you. What would you expect to be able to test in that testbed? And reach out to one of us. Mark is here, I'm here, Jan is obviously here from AMS-IX. Ingrid couldn't be here, unfortunately, today from QBIRD, but all our details are here. So if you're interested, please feel free to reach out. Happy to help you set up your quantum testbed, and let's build the quantum Internet Exchange together.
Okay, do we have any questions for Melchior?
Everybody wants beer, I think.
Yeah, it could be the case. So we're going to sort of see services like quantum attack mitigation.
There's many services possible, but I mean, a lot of work is still on the side of the research and universities. But yeah, slowly we're making steps towards science facts.
Yeah, brilliant stuff. Okay, well, I'm sure we're going to hear more updates in the future.
Sure.
So I'm sure they'll be welcoming you back to the next More IP event or another one. Okay, thanks, Melchior. Okay.